Hi, I'm Avery, and I'm going to be talking some about pumps and some biomedical applications that pumps have from a fluids lens. So first, to understand what a pump is, their main goal is to move liquids and gases, and a lot of the time they are using energy and converting it into mechanical action to move something up an elevation difference or through a large pressure gradient. And there's typically three different types of pumps: direct lifts, displacement, and gravity pumps. And those all are used in different applications according to what they're moving and how and the environment in which they are. Some common examples of where pumps are used are in wells, transporting water from very low elevation beneath the ground to surface level or above elevation. You could also think of a water slide in this example. If you're at the very base of a water slide, pumps have to be used to bring water up to the top of the slide. Also filtering, pumps are used in a lot of filtering. Large examples in industrial filtering for large bioreactors, but they can also be used in smaller things like the filter through your sink faucet. Oil and natural gases is also another example, pumping up oil or natural gases from hundreds of feet down below ground up to surface level, or even horizontally, you can go across miles to transport oil or natural gases to processing plants. However, there's a really new exciting application of pumps, and it's a valveless pump. So this is a pump that doesn't have any valves at the end to regulate flow direction. And they've been used a lot recently in biotechnology and some biomedical applications because without this valve, they're exceedingly precise and accurate. So they're able to deliver specific things to specific areas very quickly and with precision and accuracy. So examples of this would be in the body using an artificial heart pump, or an artificial filter in the kidneys, or a pump for insulin for patients with diabetes. So there's a lot of different applications, and it's super successful because of this precision. And a lot of larger pumps don't allow you to transport very small volumes. So if you're trying to just inject 500 microliters of insulin and get it to the right areas of the body, typically most pumps can't do that because they require too much volumetric flow rate. However, these valveless pumps allow for that to happen. And have been really effective in a lot of trials. However, there are also some issues that could arise because the body is a very dynamic system. So some of these issues include the type of fluid. Obviously, there are a lot of different types of fluid in the body, so it would be very difficult to make sure that the pump is in a location to only pick up and outflow one type of fluid, because it probably wouldn't have the exact same power to do, say the viscosity of blood versus the viscosity of urine. So it would have to have precision and accuracy within what fluid it would use. And then also the body undergoes pressure changes. When bodies move up in elevation, they undergo pressure changes. If your heart rate increases or decreases, there's blood flow pressure changes. So there would have to be sensors in place in these valveless pumps to make sure that they could maintain required NPSH and not undergo cavitation.